Hello everyone, my name is R. Pooja Reddy. I am from SR University. As our major project, we have selected the topic cybersecurity enhancement through malicious URL detection with ML. Our batch number 113. These are my teammates, and we are doing a project under the guidance of Mr. Sandeep Sir. And this is about the agenda that we are going to see that about the topic abstract, introduction, objectives, literature survey, existing system, problem identification, proposed methodology, system workflow, architecture of the proposed system, user case diagram, sequence diagram, implementation, results, conclusion, and future scope. It is about the abstract. In abstract, we'll be explaining that there are traditional techniques before, but as day by day the cybersecurity is increasing and malicious URLs are becoming more, and the traditional methods are not secure to find the whether the URL link is safe or not. So we are implementing more features and we are doing a project in that. Next we are going to see about the introduction. In introduction we can see that malicious URLs are modified or hacked links used for cyber attacks. They can steal data, spread viruses, or trick users into revealing sensitive information. Machine learning helps to detect the URLs by analyzing patterns like strange characters or fake domains. A strong detection system blocks harmful links before they can cause damage. This protects personal data and prevents cyber threats, making online browsing for everyone. And next about the objectives. The objectives is to implement machine learning techniques to check whether it is a malicious or not. To develop a machine learning model that can automatically identify and classify URLs as either safe or malicious based on their characters. To enhance cybersecurity measures by proactively identifying potential threats, thus reducing the risk of falling victim to online threats. To reduce dependency on traditional blacklist based detection by implementing intelligent and adaptive models. To minimize false positive and false negatives in malicious URL identification. Next we are going to see about the literature survey. These we have done literature survey in 20 papers, and these are some of the papers. The first paper is about malicious URL detection using machine learning, and the authors are Mem Murarkar and K. Deshmukh. This paper is published in 2024, and the techniques used in this paper are support vector machine and random forest. The limitations are high false positive rates and difficulties in detecting newly emerging threats. And the another paper is about machine learning for cybersecurity, detecting and preventing cyber attacks. And the authors are A. Marengo and A. Pagano. And the paper is published in 2024, and the techniques used are support vector machines, decision tree, and random forest. The limitations are machine learning models require large data sets for accurate training. And the third paper is about detecting malicious URLs using machine learning. The author is M. KVV Subbarao, and it is published in the 2023, and techniques used are support vector machine and random forest. The limitations of this is about reducing accuracy with complex phishing URLs. And next about the existing system. In existing system, detecting phishing URLs using machine learning and lexical feature based analysis, suspicious URL filtering based on logistic regression with multi-view analysis, and malicious URL detection system using combined SVM and logistic regression model. And deep learning models such as CNNs and RNNs are transformed used for feature extraction and classification. And next about the problem identification. We have identified the problem in increasing sophisticated of cyber threats, including malicious uniform resource attacks, traditional security mechanism struggle to detect evolving cyber threats effectively, high false positive and negative rates in conventional malicious URL detection methods, difficulty in identifying phishing URLs and other cyber threats in real time. And we are proposing a system as like collecting the diverse data containing malicious and safe URLs, and we are extracting the features, and we are choosing the which algorithm is suitable for that uh, cyber attack, like navy bias classifier, decision tree, random forest, KNN, and building and evaluating the model for it, and real-time monitoring system integrated with cloud-based security infrastructure for continuous threat detection. And the here the user will be giving the input link, as the system will be taking the URL from the user, and the feature extraction is done, like system will be extracting it is a lexical or host based and behavioral features of the URL, and then it will be going under the pre-processing. In pre-processing, the NLP natural language preprocessor will be doing that, the it will be cutting the unnecessary things, and like unnecessary characters are added for phishing like things, so those will be extracted from it, and then it will be going in next step. In next step, the real time response will be checking, and whether it is malicious or any alerts are there and it is phishing, it will be detecting. And next it will be analogy is used. If we find the URL is new, then it will be undergoing the unsupervised learning, and then it will be uh, using and some techniques like random forest, decision tree, and it will be getting the output, and it is a continuous process to find the URL link is suspicious or not. And next about the art will be first the data set is collected, and it is going through pre-processing, like extra information is have been removed, and then it will be analyzing, and then the new models will be trained here and testing, and then it will be evaluated whether it is a safe or it is a malicious. And then this is about the use case diagram. Here the user will be giving the uh, input and the URL link, then it will be going implementation. In implementation, when it is new, it will be training again, and it will be classified as it is a harmful or safe, then the result will be coming out. And here is the data set from the admin side, like information always will be updating as we will be training the new models, then we will be updating the information of the data set. And next about the sequence diagram. Here sequence diagram, the client will be giving the input and URL link will be implemented and checking with the data existing dataset. If it is found, then testing will be done, otherwise training and testing will be done. If the result is like normalized, then again the test is will be doing, and then we'll be finding it is safe or malicious, and then result will be found. And next part of the thing will be, it will be continued by my friend Shiva Satvika, and thank you.
Hello everyone, my name is Shivasabdika. Today I'm going to tell you about a cyber attack or phishing attack story happened to my friend Shruti, who is also working on this very same project. So we all have applied to a free TCS NQT exam, and then she gets a mail that her TCS NQT fee payment is due. And she thought maybe I have applied to a paid TCS NQT exam by mistake, and she starts proceeding with the reads the gate until she reaches the page where she have to give her credit card or debit card details for the payment. And then she messages me asking whether I also have received any mails like that, but I haven't received them. This is a case of phishing attack. These attacks happen very often these days through any social media app like WhatsApp, Telegram, Instagram, SMS, and emails. We have to be aware of these fake URLs. Our project is about URL Guardian, which is a website which determines the URL is a fake or malicious or suspicious URL and analyzes it. So, in this project for the implementation, we used Flask for Python web frameworks and HTML, CSS, JavaScript, and Bootstrap for front-end interface. And then we used natural language processing for processing the user inputs. We used the algorithms like Random Forest and KNN to train the model and detect the URLs, whether it is safe or not. We have used many algorithms like naive-Bayes algorithm and decision tree, random forest classifier, and KNN algorithms to check the accuracy. And we have obtained the most accuracy at the random forest classifier, which is of 96%. And then we got a 95.5% accuracy for the KNN algorithm. So we thought to proceed with the random forest approach, and we have trained the model. Then we have created a website named URL Guardian, which have a home page, a detect URL page, about page, sign in page, and register page. So in this website, we provide a real-time analysis of instant URL scanning and threat detection to protect you as you browse. So we have used many machine learning models in order to provide the most accuracy and give instant responses for the URLs provided with the risk analysis. And in the detection page, we have to provide the URL which we think is suspicious and analyze that. In the risk analysis, it checks the length of the URLs and if there are any special characters in the URLs and many other aspects to determine whether it is a safe, malicious, or suspicious URLs. And it also provides with the risk percentage of the URL provided. So in the about page also we have uh, explained our project conclusion. The dependence of various features of various URLs were analyzed and various features were used to determine the type of URL. By training with 6 lakhs plus URLs, we have trained it with most accuracy in order to determine whether the URL is spamming, malware, phishing, or defacement URLs. Based on the accuracy observations, the random forest made better predictions with accuracy of 96%. Future scope. Integration with AI-powered cybersecurity systems will enhance threat intelligence and automate responses by combining machine learning with AI-driven security frameworks. And the advanced deep learning models such as transformers and reinforcement learning will be implemented to improve the accuracy and adaptability. The detection models will be integrated directly into the web browsers, antivirus softwares, and firewalls to enhance user protection. The real-time detection and prevention systems will be developed to instantly block malicious URLs before they cause harm. The automated threat intelligence threat sharing will be implemented by collaborating with global cybersecurity networks to improve collective defense mechanisms. Thank you.